Okay, fine. Oh, okay. Okay, Shandip, I saw your text. So, is my screen visible and am I audible clearly?
Yes, sir.
My screen, my PPT is visible, right?
Yes.
Okay, fine. Okay. Okay, whoever has joined for the first time, let me introduce in short way. I am Bireshwar Roy. I am pursuing my fourth year PhD in the Department of Physics, ISC Bangalore. Okay. So as you know, in this course we will be discussing, and also GATE exam is I think in the next month of the first week. When is the GATE exam is scheduled? Can anyone let me?
11th Feb.
11th Feb. Okay, in the
Uh,
morning or evening? I mean, in the lunch time.
uh, I
Yes,
have
at
in
2
the
p.
afternoon shift.
Oh, there are two shifts, right?
Morning and afternoon.
Okay, okay, fine. Okay, so I mean, only two shifts are there, only on 11th, right? I mean, I don't have the information. That's why I'm asking.
Yes, sir, on 11th in the evening shift.
Okay, 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 fine. So that means 11th is Saturday. Okay, fine. So, okay, I think today or next week we will have a class. Maybe, don't know. But okay, so today's class will be little bit longer because I have planned to discuss three questions from my choices from the gate physics paper and three questions among your doubts. Not all doubts can be covered today because you will see it will take almost 2 hours and more than that to discuss six questions. Okay, anyway, if we have, I think will have a last class on the next week. So in that last class I will be only discussing the doubts. So whatever doubts you have, you can send me mail, and whatever the remaining doubts from the previous classes I'll be discussing in the next class. So I will not go for any new questions from the previous year's gate paper. Okay, fine. So first I will start with the questions from my choices, I mean from the previous year gate physics paper that I have planned to solve today. Okay, so I have divided into two part one is three questions from gate physics paper 2020, which was remaining, I mean that was from my part and I have to finish that. Okay, and second part will be from your doubts question. So I have chosen three questions and I will try to clear your doubts. Okay, so part one. Okay, so this is the question. This is a very easy questions. I will expect that everyone can solve this from basic quantum mechanics. So this is a question from GATE Physics paper 2020. This is a numerical answer type question, 2 marks, and the topic of the question is quantum mechanics. The question is a hydrogen atom is in orbital angular momentum state L, m, where m equals to L. If L vector, the angular momentum vector, lies on a cone which makes an angle 30° with respect to the z axis, then what is the value of this L? You have to tell that. So, this is a very easy question. Please try to solve this and let me know the answer. And if you have any doubts also, you can ask me in between that. Is the question is clear to everyone? Any doubt about the question? Anyone? Amit, Sejal, anyone there? Aparna?
Yes, sir, doing it.
Okay, the question is understandable,
I've
right?
tried. Yes.
Okay, fine.
Yes.
Okay, okay. Just try to solve this. This is a easy question. Don't you have to think? Don't have to think very in a very difficult way. The basic thing, if you know, then you can solve this. Only you have to apply the things. I mean, the z component will have a which cosine on sine component. So you have to just consider that thing. That's the hint. and also you have to apply the eigenvalues of your. So okay, so let me ask one thing. So first, this L, what is this L and what is this L? Please tell me. I think everyone should know. What does it signify, L and M, these quantum numbers? Anyone?
So L tells us the magnitude of the orbital quantum number, orbital angular momentum uh, denotes the orbital angular momentum quantum number, while M tells us the precise orientation of the given the magnitude.
Exactly. So basically, yeah, that's the correct. So that's the thing. M, that signifies the your z component basically of your angular momentum, right? So that's the component along z axis. So that's the thing. So Lz component will give you a principal quantum number eigenvalue, you can say m h cut, and your L square, that will give you what? What eigenvalue? Can anyone say the eigenvalue of L square, operator?
L n plus 1
Ha,
h
sorry.
L plus 1 h cut square.
Yes, exactly. So you know what is so everything you now I have you know the informations about this. So you know what L square is giving. So basically, so if you have the L square eigenvalue, then what is the eigenvalue of L? That's the root square of that, right? Right, Amit?
Yes, sir.
Yes. So you know the eigenvalue of L, you know the eigenvalue of Lz. Just apply that cosine rule and try to find the value of L from the equation. I mean, is my that hints are understandable? What I have given told you.
So 3.
Yes. As the answer is, I will not spend much time on this. This is a very easy question. Okay. I think whoever has not done this, please see the solution. You will understand. This was very easy. So Amit, you said 3, right?
Yes, sir.
Okay, good. Okay, so going to the solution. So for an angular momentum state Lm, we have, I mean, the mod of Lz or z component of the angular momentum is basically your the projection of the total angular momentum along z axis. So it will give the cosine component, right? So mod of Lz equals to mod of L times cos theta. Now Lz has the eigenvalue m h cut and L has the eigenvalue L root over L into L plus 1 times h cut. Now you know you have the equation, you just put it here, m h cut equals to root over L into L plus 1 h cut cos theta. Now according to the equation, you are said m equals to L here. So m takes the maximum value of its the azimuthal quantum number takes the maximum value. Okay, so you just put the equation L here and you will see, so you will get L h cut time equals to root over L into L plus 1 times h cut cos 30 degree, and it is also given in the question the L is making 30 degree with the z axis. Okay, so just so cos 30 degree is root 3 by 2. Now square both sides, so we will get L squared equals to L square plus L times 3 by 4. Just multiply the 4 here, 4 L square is equal to 3L square plus 3L. From here you will get L equals to 3. Is it okay? Is it understandable clearly?
Yes.
Anyone has any doubt about this?
No, sir.
Okay. So this was a very easy question and the answer is 3 for this question. Already I have discussed. Okay, going to the next question. Okay. So this is also from quantum mechanics from GATE physics paper 2020. This is a numerical answer type question having 2 marks. The question is, an electron in a hydrogen atom is in the state n equals to 3, L equals to 2, m equals to minus 2. Let Ly cap, that is the y component of the angular momentum, orbital angular momentum operator denotes the so it is given in the question, and if so it has been said if your del of Ly cap whole square, so that is basically your variance square equals to alpha h cut square, then you have to find the value of alpha a. So does anyone know how to, I mean, find the this quantity del of Ly cap whole square or del of Lx cap whole square? It has the
No, sir.
okay. Anyone has gone through the, I mean, recap the formula? So basically we usually solve this problem in the orbital angular momentum chapter. So I will not say you have to remember this thing, but if you remember it will be easier for you, otherwise it will be lengthy to solve. Some questions comes, I mean, if you know the formulas directly, then it will be easier for you in the exam. It will save your time, otherwise it will be little bit lengthy. So okay, so if you don't know,
So,
then yeah,
uh, will it not be s- expectation value of Ly square minus square of the expectation value of
That's
Ly?
why I said that's variance square. So it has been, that's the thing, the sigma square, sigma Ly square, that's the thing.
Yes, ma'am.
Yes. So so basically you have to calculate here uh, average of your Ly and average of Ly square, and then you have to apply in the formula, right? Sejal, you are Sejal,
Yes,
right?
sir.
Yeah. So basically, if you don't know the formula, if you had not solved this previously, then please try to find what is the average of Ly for these states and average of Ly square. If you just can do that, then just you have to subtract that's the thing. You will find the in multiple of h cut square the value. So then you will can tell about the alpha value. So I mean, is it clear to everyone what you have to find here? Anyone has any doubt, please ask me. This is a little bit tricky question if you don't know how to solve this, because I mean some questions involve some tricks which you, if you not don't apply, then it will be difficult to solve. But at least I want you to try. At least the approach I want to hear from you guys. Then I will discuss, and that will be helpful. The solution. So how will you find the average of Ly? Can anyone say? You know average of LZ. LZ though you already know because it has image cut eigenvalue. So you can find the expectation value of LZ. But how will you find the Ly? What will you do for that?
So we can perhaps use the fact that L gives the average value of capital L and capital L squared, and that can be written in terms of Lx squared plus Ly squared plus Lz squared, and Lz squared is known to us, and Lx and Ly are equal, so that could give us the value of
So
Ly.
what it will give? Can you say that thing?
So it will give us 4 minus uh,
1.
With what is one? I didn't get the point.
Ma'am,
You who is saying one? That is the answer, or
The L
alpha
value.
value.
okay? So you are I forgot your name. Who told one?
Prajwal.
Prajal. Okay. Okay, just hold on. Sejal, you were saying something, just to continue that.
yes, sir. I'm also just calculating it.
Yeah. So, what's the formula you are getting then?
The formula was L square equals Lx squared plus Ly squared plus Lz
No,
squared.
that I
So,
understood. So, after applying that concept, I am asking what are you getting for
uh,
this del Ly square? Just, just do that
Sir,
and let me know.
okay, okay, sir.
Okay. But that is not the way, but I will consider this thing. I think you will get the correct
Square,
formula.
square. Sir, I got H cut square.
No, no, not for this state, for general state, L and M. You don't first don't do for L2 M2. Just do for a
sir,
general state LM.
sir, we can write L square equal to L into L plus 1.
L, sorry.
L square, capital L square is equal to small l into L plus 1 h cross square.
How does it help that?
Then we will put L equal to 2.
L equals to 2. So what will it give for this quantity? You have to find
I
this.
am getting this quantity 1.
No, how are you getting that? That I am asking.
Okay. Sir, मैं L square x capital L square x plus capital L y square plus
Huh.
capital L z square is equal to capital L square.
Mm-hmm.
We know that L square x equal to L square y.
Why it should be?
L is equal to L square y equal to L square minus L z square divided by 2.
Sorry. Why it should be? I mean, if it's equal every time.
Is L square y?
So you are saying Lx squared equals to Ly square, right?
Yes, sir.
Why it should be? That I am asking.
Sir, I don't remember, but uh, आई डेंट सॉरी स्पेन में हम देखते हैं कि एस स्क्वायर एक्स इक्वल टू एस स्क्वायर वाई आता है, तो सर वहाँ से ये कॉन्सेप्ट मतलब वहाँ से ये है.
There's some reason. Not every time it's true. Okay. Anyway, I will consider this because some of the books did write that. There is some reason. Okay. So after that, what are you getting?
Sir,
आफ्टर
Yeah.
गेटिंग एल.
sir, your voice is echoing.
Sorry.
Voices, there is echo in the voice.
Am I audible clearly?
यस सर.
Okay.
Double voice.
I
Sir,
will.
your voice is encountering twice, please. So
Okay.
that's why your voice is
Okay.
coming twice.
Okay. Just wait. Just wait. I am leaving and I am joining again.
सर योर वॉइस इज क्लियरली, देयर इज नो
Just
नॉइस.
one. Am I audible now clearly?
यस सर.
Okay. Just let me share my screen. Is my screen visible now?
Yes, sir.
यस सर.
Okay. Just one minute. Let me check it's recording or not. Okay, fine. Okay. What happened? My screen is visible, right?
No, sir.
No. Oh, what happened? Something is going wrong. Okay, let me share it again. Now it's visible.
Yes.
Yes,
यस
sir.
सर.
Okay, okay, fine. Now everything is clear. Okay, so Harish, then what are you doing? Okay, I will consider that Lx squared equals to Ly squared, that expectation value
ओके
of. Okay.
सर, 2 L square y plus L square z equal to capital L square. Okay. 2 L square y equal to L square minus Lz square. That equal again after that L square y equal to L square minus L square z divided by 2. Okay. We can write, we know that L equal to under the root L into L plus 1 h cross. Okay. And Lz equal to mh cross, where capital L square, then we can write this L into L plus 1 h cross square minus Lz equal to mh cross, that means Lz equal to m square h cross square divided by 2. Now in this question, L equal to given L equal to 2, then we can write 2 into 2 plus 1 h cross square minus m equal to minus 2, that means minus 2 square h cross square divided by 2. Okay. 2 into 3 6 h cross square minus minus 2 square equal to plus 4, that means 4 h cross square divided by 2. 6
Okay.
minus 4 equal to 2 h cross square divided by 2 equal to h cross square, that means alpha equal to 1.
Okay, I got your point. So answer is correct. Okay. So I mean that's the thing is that why Lx equals to Ly for hydrogen atom. So that is directly said, right? But how it comes? or mathematically you can prove that why it happens. So I will go into that case because sometime you may need to apply that procedure also in some questions. So you cannot, I mean, this question, in this question it will be easier if you apply that concept. Okay, but what I will discuss, that will be a little bit lengthy, but that will be helpful in some way. Okay.
So is it
Huh.
because the hydrogen atom has azimuthal symmetry?
Yes, that's the thing. That's the thing. But I will solve it in a general way. So whatever I will discuss, that will be helpful for other things. Okay.
Sir, is this first question of today's session?
No, this is the second question. You missed first question, I think. Okay, then I
And
am
so,
go.
moreover, this
Yeah.
this method is only giving us the expectation value of Ly squared,
Yes.
not the complete variance.
What Ly? What about Ly then?
Yes, so that's remaining.
Harish, what about Ly? How will you find that average value of
LLY.
Ly?
As the average value of del y.
Ly.
Sir, can I guess something?
Ah, yeah. Please tell.
Sir, as Amit said that it has azimuthal symmetry, right?
Mm-hmm.
So you can just see that L is equal to 2 and M, which is directed in Z direction,
Mm-hmm.
it is aligning with L.
Mm-hmm. Mm-hmm.
So you can say that Ly is coming 0.
Ly, from that, how can you say Ly equals to 0? Because it's aligning only Z. But your that will give you angle theta, not phi, right? You can't say about the xy plane from this because L corresponds to the total L, okay, and M corresponds to your Z component, right?
Yes, sir.
But it doesn't mean you don't have any component along the.
No, sir, I am saying that. Okay.
You can't say directly from that. Uh,
It's the d orbital, right? So it's not spherical, but double means dumbbell shaped.
Okay, there will be lots of question. So let me tell one thing, and you have to tell me how to do that. I will tell you the answer. Average
So
of average of Ly will be always 0. Now we have to prove that how it comes.
so if we know the expectation values, no, actually the eigenvalues for L plus and L minus, then we can do it much faster.
L plus, and you are saying raising and lowering operator, that creation
Yes.
annihilation operator, right?
Yes.
That's the way I will be doing this thing, and you should know these concepts of raising and lowering converter. Sometimes it will be very helpful to know that to solve some questions. So that's, and using that you can show your Lx square, averaging of Lx square and average of Ly square is equal. Okay, uh, you can't directly say, because in some cases it is not equal always, because it had azimuthal symmetry in this case, that's why it is coming equal. That's the thing. Okay, so okay, anyway, I'll be going to the anyone want to say
सर
something?
सर आपने एक क्वेश्चन पूछा था मुझसे क्या
क्या?
किसकी एक्सपेक्टेशन एवरेज वैल्यू पूछ रहे थे सर
Ly.
एल वाई की सर 0
That's why I'm saying how it's coming.
आई डोंट नो बट
That's why Amit said that already. Okay, anyway, I'll be going through that little bit theory part also. That will be helpful. Just focus on this.
So,
Yeah.
so because we are using the raising and lowering operators, so the M values will change. So when we sandwich, we won't get the same
Exactly,
bra.
exactly,
So
exactly.
the
So basically, it will
delta
change the
will be
M
negative.
value when you will just find the elements of, I mean, average of Ly or average of Lx. So the inner product will give you 0. That's the thing, right? Am I?
Yes, sir.
Yes. So anyway, I'll be discussing all the things, and okay, fine. So focus on the solution part. I will be going through it slowly, and you can ask me question. Okay. So the state of the electron. So basically, I am talking about the angular momentum state, not considering on the principal quantum number in, because that doesn't mean much here. That will be LML state. Now here one two things I will be using, that is raising operator and lowering operator. So I think you know what is raising operator. We have encountered this thing also in the quantum three-dimensional quantum harmonic oscillator problem also. Okay. So raising operator is defined as this: L cap plus equals to Lx cap plus I Ly cap, and lowering operator is L cap minus equals to Lx cap minus I Ly cap. So from this you can find the Lx cap and Ly cap in terms of L cap, L plus cap and L minus cap, right. Now this thing I will not prove this, you will find in the textbook. You have to remember this thing, sometime it is asked in the questions directly, so you have to apply this. If you apply L plus cap on the state LML, then it will give this. So what, some value that is root over L minus ML times L plus ML plus 1, and it will raise the state by 1. So basically it will raise the ML value by 1. Similarly, L cap minus, when it will be operated on this state LML, then it will give the value root over L plus ML times L minus ML plus 1, and it will lower the value ML value by 1. So these two things you have to know, you have to remember. Okay. Now let us see what is the expectation value of this L plus cap and L minus cap. So just operate this L plus operator on this LML. So you will get this, and then you have to take the inner product of this state with this state, right. Now as there you can see ML dash, and you will get some ML plus 1 state after operating L cap plus. So here you can write this as delta of ML dash comma ML plus 1. If they both are equal, this ML dash and ML plus 1, then it will be 1, otherwise it will be 0. Similarly, you can find the expectation value of this L cap minus. Okay, this it will be this. I am not reading this anyway. You can see this, and two more thing we need, that is L cap. What is the expectation value of L cap plus square? L plus cap square. So how can we find that? First, operate L cap plus on this state. So that will give this times this state. Then again operate that L cap plus L plus cap operator on this, that raising state, raised state, that is L ML plus 1. So you will basically get two terms. Two times you have to operate L cap plus, and you will get this delta function. So here it will be 0, it will be 1 if your ML dash equals to ML plus 2. Similarly, so is it this is totally mathematics. You can any doubt in this?
No, sir.
I will share the solution. You can just look into that and you can verify these things. Okay.
सर ये फॉर्मूले थोड़े काफी जटिल है, मतलब कंफ्यूजन
No,
रहता है
no, no,
सर.
no. These formulas are complex. So basically, you should remember this. Okay. So you will see the final formula will be very easy, because lots of terms will be cancelled out. Okay. Just to come to the final result, I am discussing this, because you have to do this, otherwise you can't lead to the final result. Okay. Anyway, these things are asked in the usually theory questions, I mean in exams, college exams. Okay, fine. So we have found this expectation value of L plus cap, L minus cap, L plus square, and L minus square, right. Now we have to find this quantity, right, this del Ly cap whole square. So this means actually your expectation value of Ly square and minus expectation of Ly whole square, right. So you have to find this quantity separately and this quantity separately. Now let us find this Ly cap, this expectation value of Ly cap. So this will be 0. Why? Because Ly cap is basically, we have already seen Ly cap can be represented by this L minus I by 2 times L minus minus L plus. Now this L plus will raise this state by 1 and L minus will raise this state by, sorry, it will lower this state by 1, right, and when we will take the inner product we will get 0, right. So, basically expectation value of Lx also will give 0. So, expectation value of Ly and Lx is always 0. Okay. Is it clear?
Yes, sir.
Okay, fine. Now, let us come to the Ly square. First, we'll find this operator Ly square. How can we represent this using the L plus and L minus? So, what you have to do? You have to multiply this Ly 2 times and you will get minus 1 by 4 times L minus square minus L minus L plus minus L plus L minus and plus L plus square, and do not confuse these two quantities are equal because they do not commute. Okay. There are some commutation relation of L minus and L plus. So, it will not be equal L minus L plus and L plus L minus. Okay. So, what is L plus L minus now? So, you do not know this, what is the expectation value of this, we can't find directly. So, what we will do, we will just find this quantity in terms of Lx Ly. So, L plus operator is Lx plus Ily and L minus is L minus Lx minus Ily. Just multiply these things. So, we will get Lx square plus Ly square minus I times this commutation, that means Lx cap Ly cap minus Lx cap Ly sorry Ly cap Lx cap sorry plus, I just confused this thing. So, is it clear to everyone why we are getting this commutation?
Yes, sir.
Okay,
Yes, sir.
I have just written directly here. Okay, so
Sir,
yeah,
Alex Ly equal to IH cross LZ, right?
yes, that's why. So, basically what we know, we want to apply that thing. We will represent this thing in by using that known quantities, right. So, Lx square Ly square is basically L square minus Lz square, right, and this quantity is your I h cut Lz. So, it will give plus h cut Lz, right. Is it okay?
Yes, sir.
Similarly, you can find the L minus L plus. So, it will give L square minus Lz square plus minus h cut Lz. Okay, fine.
Yeah.
Okay. So, from this, putting these things in the this term, this Ly square, you will get minus 1 by 4 times L minus square plus L plus square minus. So, L plus L minus is basically your minus L minus L plus. So, basically L square minus Lz square minus h cut Lz minus L plus L minus. So, it will, you have to write this. So, basically it will be L square minus Lz square plus h cut Lz. So, everything is converted now into L minus, L plus, L and Lz, right. And you know how to find the expectation value of L plus, L minus, L square, so you know already, Lz you know already, right. So, that is how we have done this much of calculations. So, basically finally we are getting Ly square is equal to half of L square minus half of Lz square minus 1 by 4 L plus square minus 1 by 4 L minus square. Okay. So, now we have to find the expectation value. Now, it is easy. So, for that we will take this expectation of Ly square. So, now write the Ly square in terms of this. So, you can do it verbally, you do not have to go for copy and pen. So, L square will give what? L into L plus 1 h cut square, right, because that is the eigen operator of LML state, right. Can you say yes? Am I
Yes, sir.
audible? Okay. Lz you know, that is ml h cut whole square, it will give Lz square, right. Now, L
Yes.
plus square. L plus square, now we have already discussed the L plus square, this element, it will be non-zero when your ml dash and ml plus 2 is equal, but here your both m are same, right. You can see. So, anyway you are not getting ml equals to ml will not give you a non-zero quantity here. Am I understandable?
Yes, sir.
Okay. So, this quantity expectation value of will be 0 for this state. Okay. and L minus also will give 0, right? Because L minus will lower the state 2 times and the inner product will be 0. That's the thing. That's a simple thing. But when it will be non-zero, that I have discussed earlier. Okay. So basically, first two quantity will be non-zero. First, then second two, last two quantity will be 0. So from here, you are getting half of L into L plus 1 h cut square minus half of ml h cut whole square. So that we have used this property. So your Ly cap square, so Ly cap square, this average expectation value of this, it will be h cut square times L into L plus 1 minus ml square. This is a general formula. This also true for Lx square, and that's why you can say that Ly cap square, I mean that your average value of Ly square equal, but not every time. It has some certain limitation. But from calculation, we can show that from hydrogen it is equal. Okay. So you should remember this formula. I think this is not hard to remember, right? Has anyone see this formula by any way in books? I mean, I
Sir,
think
nahi.
every books discuss these things. Average value of Ly square, Lx square, almost. I have seen in I think gasworks it has been discussed already.
Griffith.
Yeah, Griffiths also I think it has. I
Griffith.
didn't check, but it has. If it is not have, it is in the question also. You should when you are reading the chapters, you should solve the questions also. Hmm. So essentially, what we are getting, del of Ly cap whole square is basically your expectation value of Ly cap minus Ly cap expression of Ly cap square, right? So this quantity is your this, and this is 0 we have obtained. So in general, for LML state, this will be your formula for uh, del Ly cap whole square. Okay, now we will apply the
Sir,
values.
1 minute.
Yeah.
सर अभी हमने डेल एल वाई का निकाला ये फॉर्मूला, क्या अगर हम डेल एल एक्स के लिए निकालते तो हमें सेम
मैं I can't hear you your question properly.
सर मेरे कहने का मतलब है कि अभी हमने एल एल वाई स्क्वायर का एक्सपेक्टेशन वैल्यू निकाला, ठीक है, फिर डेल एल एल वाई का निकाला है, तो अगर हम डेल एल एक्स का निकालना चाहें तो हमें सेम रिजल्ट मिलेगा.
Same result मिलेगा. Do you know why?
और because एल एक्स एंड एल वाई इक्वल.
Okay. No. The thing is, you can from mathematics when you will do the mathematics, I can tell you don't have to calculate individually the Lx what is the Lx square average value of Lx square. So the thing is that I have to go to the step. Just give me a minute. So just give me a minute. I have to check whether I have written this thing or not. Okay. Okay. So basically one property you have to apply, that is the complex conjugate of this is this. That's the thing, right? So I mean I forgot the step where you have to apply this thing. So if you know the this quantity Ly square, then you can directly say about the Lx square. So just have to check. You can try with that. So just let me check one thing. If you write this Lx square, then you will get some plus minus. There will be something. I don't know. I have to check. So when you will do the calculation, you have to just write it as, I mean, is the state this thing star, because it's a complex conjugate of that. You have to apply that property. I forgot the steps. I have to check again. Anyway, you can do it individually. Whatever steps I have shown here for Lx also, you will find the same thing. You can verify these things. Okay. Because this some mathematics
डेल एल
involved, I
जेड के
can't
लिए
do
भी
directly. But you should you can believe me, because I know this thing, because Lx square average expectation value of x square is the same. They are same. Okay. You will find in the books also. Okay, Harish. Okay.
Yes, sir.
So this is the general formula. So if you can remember this thing, then you don't have to, I mean, think about this much thing, right? You can directly apply this formula and you will find the answer. And also what Sejal or other people have said, the thing, That is correct, obviously, for hydrogen atom. Anyway, um, so from this, what we have obtained, n equals to 3, L equals to 2, ml minus 2, just put the values here, you will get it's h square square. So the alpha value is 1. Okay, fine. Whatever I have discussed, the lots of thing has been discussed. I think you could recap these things. Is it okay?
Sir,
Yeah.
Yes, sir.
sir, can you explain that step why that delta equal to 0?
Delta equals to 0. Which step? Can you say this one?
L plus expectation when you were doing L plus and L minus
Oh, acha,
square.
acha, acha, acha. This step, this term, right? So
No, sir.
when ml equal this ml and this ml dash ml are equal, then we say this as expectation value of L plus. So here I have generalized these things. So it can be 0, it can be non-zero, and for that what we have considered here, ml dash and ml to both different states, right? So it will give you h cut times root over this times delta function of ml dash ml plus 1. So if you have ml dash equals to ml, so both are same, then you can't have ml equals to ml plus 1, right? So it will be always 0. You understand my point?
Yes, sir.
So basically what is happening, L plus is raising the state by 1. So ml will be ml plus 1. Then after that you will take a inner product, right? If the inner product, in the inner product the states are not same, then they are orthogonal, right? They will give 0. You got my point? What I am trying to say?
Yes, sir.
So here all the states are orthogonal, right? So you have to apply that property. That's why this the delta function is coming from the orthogonal property. Okay. Anyone else? Any questions about this? I mean, not only this, the things theory part I have discussed.
So this is applicable for only hydrogen atom or any.
This thing is applicable for any LML state, not only hydrogen atom state.
No, sir. The final formula.
Final formula is applicable for. I think okay. For LML state, the if you have the LZMH cut, um, no, I don't think so. It is applicable for everything because okay. Let me check one thing. Mm, can anyone say this thing? Is it applicable for
Only for hydrogen atom, in my opinion.
because I forgot the reason. Actually, I have to go back to that the formulation part, how it starts.
Sir,
I forgot the
I have
initial
another opinion.
concepts.
Uh,
Can
sir,
anyone?
this type of
Huh,
yeah, sir, this type of question asked only on hydrogen atom.
yes, that I
Whenever
know,
we
but
check previous year question.
yes, yes, because this is in the syllabus, only thing we have, right? But the question from him is this applicable for any ML state for any system? I don't think so, but I forgot the reason actually. I knew that. I forgot there are some reason comes from the formulation, how we formulate the problem, the hydrogen atom problem. It comes from that. Okay, but I don't think so. It is applicable for everything. Okay. Sorry for that. I forgot that thing actually. I have to search the books for that. Okay. Anyway, you don't have to worry about much because the questions will be asked from the hydrogen atom only, not beyond that. Okay.
So because if we apply this in the first question, no, it is giving L value something different.
Sorry, sorry.
So the first question which we did, no,
The
right now,
first question.
if
This
we
question.
if we apply Lx equal to Ly in that question, no, then it's coming something different. The L value.
Oh, acha, acha. You are saying Lx equals to Ly.
Yes, sir.
No, Lx equals to Ly, it is not true, but the expectation value of Lx square and equals to equals to expression value of Ly square. Lx may not be equal to Ly. That's not the thing.
Okay.
Yeah, fine. So we solved two
So,
questions. Ah, yeah.
won't that azimuthal symmetry come directly from the central potential of
Yeah,
that
yeah, yeah,
fundamental
yeah,
derivative?
yeah, yeah. That's the thing. Central from because of the. I mean, if you have potential independent of the that azimuthal symmetry, that the central potential, then you will have the azimuthal symmetry, right? That's
Yes,
the
sir.
yeah. That's the thing. Okay, fine. I think I discussed some questions sent by Harish. Also the spin LS coupling on LS coupling, how it varies for different, how it is different from the central potential. I mean central potential, but depending on the theta, not some, because Coulombic interaction is independent of theta, right? Also, but if you have the theta dependence potential, then what how can it can vary the in the LS coupling also. Some question was sent by Harish. I discussed 2-3 weeks back. Do you remember that thing? So the nature of potential affects a lot your results. So you have to be very careful what kind of potential is asked in your question. Okay. Anyway, so two important questions from hydrogen atom, or you can say quantum mechanics. Now last question for part 1. So this question is easy. I hope so everyone can do that. Anyway, this question is from Gate Physics paper 2020. This is the MCQ question having 2 marks, and topic of the question is solid state physics. Consider a two-dimensional crystal with 3 atoms in the basis. The number of allowed optical branches N and acoustic branches M due to the lattice vibrations are. So there are 4 options given. The NM set is 2 comma 4, NM set is 3 comma 3, NM set is 4 comma 2, and NM value is 1 comma 5. So is the question is clear to everyone? Any doubt about the question?
So the number of acoustic
Hmm.
branches is always two.
Always?
Two.
Okay. Then what will be the number of optical branches then?
2p minus 2.
Degrees of freedom minus two.
Degrees
Yes.
of freedom.
2p
Okay.
minus 2.
So what will be the answer then?
4. p equal to
So
3.
one thing
Two
you
comma
can one thing you can just notice. I mean, if you the answer will be 4 comma 2. One thing you can notice, the n plus m is always 6 here, right? In every options also. If you don't
Yes,
know,
sir.
okay. So basically, why it is happening? Okay, I will be discussing in the solution anyway. I will not. I think you people know these things. So I'll just highlight the key points. Not I will discuss the phonon or lattice vibration part because it is broad topic, right? Anyway, I'll generalize the things. So number of phonon branches in a solid. So I'll give you this information. You can remember these things, and it will be very helpful. One at least one question will be asked from this topic. So let the number of the atoms in primitive cell is p. So basically your number of bases is p. So if you have number of whatever is the number of bases, you will be total phonon branches of that number. So basically, in one dimension. So basically, your total number of branches will be number of the dimensionality of the system times your number of bases. That's the thing, right? That's the degrees of freedom you are saying, right? Right, Amit?
Yes, sir.
Okay. So in one dimension, you have total branches p. Why? Because you have p number of bases and you have dimensionality 1. In two dimension, it will be 2p, and in three dimension, it will be 3p total branches. Now, acoustic branches they only is equal to your dimensionality. Why? Because in one dimension, you can have only one vibration, one type of vibration in one direction only. In two dimension you can have only in the plane, that is two direction, and three dimension three direction, and now remaining branches will give you the optical branch, right? That's the thing, that's the concept we use for higher dimension system, because only if you consider a two basis one dimensional system, then you will get one acoustic, one optical branch, right? if you consider two-dimensional system with with two bases, then what will be the number of your acoustic and optical branch? Can anyone say?
2 and 4.
No, you have two bases and two-dimensional system, not three bases, two bases.
Okay.
So total number of branches will be 4, and in two-dimensional you have acoustic branch 2, so you will have optical branch also 2, right?
Yes,
Yes.
sir.
Okay, so that's the simple thing.
I
So
am not, sir. Can you repeat?
what you are not understanding, please tell me.
Sir, if we have two atom bases, then total number of branch.
So see, the general thing is that first you have to know the dimensionality of your system. If you have, suppose say your system has dimension n, okay. Harish,
Yes.
you are listening, right?
Yes, yes, yes.
And your number of bases is p.
Yes.
Then total number of branch, acoustic plus
Right.
optical will be n times p.
लाइक सर हमारे पास जैसे थ्री डी कोई लैटिस है, ठीक है, और हमारे पास वो ट्राइएटॉमिक है, ठीक है,
Triatomic,
ट्राइएटॉमिक
in
बेस.
a primitive cell you have 3 atoms, that you were saying?
यस, थ्री एटम बेसिस.
3 atom basis, okay, fine.
देन टोटल नंबर ब्रांच विल बी 9,
9,
राइट?
right.
या आई गॉट इट.
That's the thing. So for that you don't have to go for the phonon equations or anything. This is the simple thing you can do. Only thing you have to know the what is the number of bases in the primitive cell. Sometime in the questions it is confusing. From that you have to find the number of primitive cell first. Okay, you have to see the question properly. Okay, so I think this thing is known to everyone. So in our question, two-dimensional with three bases, right? So for two-dimensional with three bases, that means your dimensionality is 2 and number of bases is 3. So your total number of branches will be 6. Number of acoustic branch will be number of your dimension, the dimensionality of your system, that will be 2. So it is m equals to 2, and remaining will be your optical branches. So it will be 6 minus 2, that is 4. So n comma m, this set will be 4 comma 2. So option C is correct, right? Any doubt about this?
नो सर.
Okay, so this thing you should remember.
No.
I think it is not hard to remember. You can easily remember this thing, the concepts. This, you don't have to remember the formula. Just you remember the total branches is number dimensionality times number of bases, and acoustic branch number will be your dimensionality of the system. That's the thing. Okay, fine. Okay, so in first 1 hour we have already discussed 3 questions. I think it will be it is helpful for you. Now I will go to the part 2. So any questions for the part 1? Anyone? You want to see some slide or anything? Because I will be going to the now next part.
No, sir.
Okay. Just give me 1 minute break. Okay. Then I will start the second part. Okay. Because
Okay.
I had to talk for long, right? Just give me 1 minute or 2 minutes. I will take a break, short break, and I will start the second part. Just don't leave. Because some question I will discuss 2 questions. I think 2 questions from scattering problem which Harish sent me. I thought it will be I think it will be important for you because every time question is asked from scattering, and from Sejal's part I will discuss the your 2 coil problem, and in the next class I will discuss your both the things. You told me to discuss the primitive cell, right? Because for that I have to spend more time. Okay, so I thought it will be convenient for me to discuss separately. Okay, Sejal. So I will discuss the 2 coil part today. Okay.
Yes, sir.
Okay, and also your metallicity of magnetism, I did not get time because I had to do these things and some other questions. Okay, and so I think in the next class I will discuss Sejal's 2 doubts, and if anyone can send me any question, then I can do that. I will not go for any previous year GATE questions because my task was to finish my part from the GATE physics paper 2020 and 2021. I think within this class, I mean up to this class, I have finished everything from the three topics, that is solid state physics, quantum mechanics, and electromagnetism. Okay, so now also we don't have much time. Okay, I'll take 2 minutes break. Okay, then I will start. Just hold on. Okay, so we can start. Okay, I am sharing my
Okay,
screen.
sir.
Okay. Is my screen visible? I don't know.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. Fine. So now I am starting with the doubt questions. So I just one minute. Elizabeth. So I want everyone to participate in this, although the question has been sent by particular student. Okay. This question is very easy. Anyway, I don't know why Harish want me to discuss this. So the question is get from Gate Physics Paper 2016. This is an MCQ type question having 1 mark. The question is quantum mechanics. The scattering of particles by a potential can be analyzed by Born approximation. In particular, if the scattered wave is replaced by an appropriate plane wave, the corresponding Born approximation is known as the first Born approximation. Such as approximation is valid for four options are given: large incident energies and weak scattering potentials. Option B, large incident energies, strong scattering potentials. Option C, small incident energies, weak scattering potentials. Option D, small incident energies and strong scattering potentials. So I think this question is very simple. And what will be the answer? Can anyone say? You don't have to do any calculation for this. This is the informative question actually.
The A, I guess.
Why it should be A? I mean, there should be
Yes,
some
sir.
reason.
Same here.
Just by imagination.
By imagination. You are
Yes, means
guessing.
yeah, no, not guessing means if the incident energy is
Hmm.
large, then the rays will just pass through, and if the scattering potential is also low, it
Huh.
will not have enough energy to scatter the particles.
Yes. So the thing is, yes, okay. So answer will be A, and why it should be? This the thing. The answer is given in this line. If the scattered wave is replaced by appropriate plane wave. So when your energy is large, the incident energy particle energy is large, incident energy, or your scattering potential is weaker than your energy of the incident particle, then it will not deflect your particle much, so your wave function will not be deformed much. So you can consider the scattered wave function as a plane wave. You can approximate that, because before uh, before interaction with the scatterer, it will be plane wave, right? But after scattering, it may be deformed depending on your energy of the particle as well as your scattering potential, right? Am I understandable this thing?
Yes, sir.
Okay, but anyway, in the solution part, I will be discussing more thing that will be helpful in the second question. Okay, just if you have forgotten these things, the scattering cross section part, how to calculate that, I will be discussing the theory part. Please look into that properly, because in the second question, I want you to solve this question, the second question. Okay, because the solution of this question will be helpful in the second question I will be coming. Okay, okay. So, what's the picture of scattering in quantum mechanics? You have some beam of particles. My screen is visible, right? Properly?
Yes, sir.
Okay,
Yes, sir.
you have some beam of particles having mass m, and we consider the beam of particles having the wave function, that is a plane wave function. They are considered to be plane wave because there are no interaction, they are free to move, and it has wave vector k. Now you have a scatter sitting there along the z axis. Okay, so when the beams will comes closer to the scatterer, it will start to interact. Basically, there will be some interaction that may be Coulombic or anything else, that depends on your system. Then it will start to deflect. It will start to deflect. It will scatter in the possible in every possible direction. So you will have scattered wave this direction, this direction, direction. So it basically it will, uh, I mean, scatter like along the surface of the sphere, right? It may not be sphere, but here I have shown it. It's sphere. It will scatter in all the directions. Now, what we define, so this is your target potential V, and we also define a sphere having radius r naught. This r naught is known as range of scattering potential. So, in this region, the particle will feel the scattering potential, and beyond that, it will not feel. So, basically, it will act as a free particle beyond this sphere, beyond this region. Okay. Now, let us consider some particles have scattered along this direction, which is making theta with this z direction. So, this differential cross section through which the some number of particle, that is dn, you can tell it dn is getting scattered. So, it is given by this r square, that is the distance from your scatterer times this solid angle made by this area cross section, right. So, this is the wave scattered in d omega, that is in this solid angle d omega along theta phi direction, because you will have also phi dependence of the scattering, right. It may vary along your xy plane also, not only angle with the z direction. Okay, is this picture clear?
Yes, sir.
Yes, sir.
Okay, this is the first thing is discussed in the textbook about the scattering problem. Okay, so some fact I will just point it out, that summarize this thing. Total number of collisions over the duration of the experiment, the scattering experiment, is proportional to total number of incident particles. Obviously, if your number of particles is larger, then your scattering will be larger. Number of target particles per unit area in the path of the beam. If your number of scatterers are larger, then you will have large number of scattering. That's obvious. You can tell it by your common sense. The number of particles scattered into an elementary solid angle d omega, that is, you know, the solid angle is defined as this sin theta d theta d phi, right. So, is proportional to your differential cross section. So, differential cross section is what? That is defined as d sigma d omega. Now, I will discuss what is d sigma d omega after this. So, just remember this differential cross section is your d sigma d omega. Sometimes it is written as direct sigma as a function of theta phi in some books, but it is basically d sigma d omega. But do not confuse with this. Some books write it as direct sigma of theta comma phi. That is differential cross section, but both are the same thing. Okay. So, it is defined as number of particles scattered into the solid angle d omega equals to sin theta d theta d phi in a direction theta comma phi per unit time per unit incident flux. So, what is incident flux? Can anyone say? What is how you define the flux? You know, right? Flux, electrical flux, magnetic flux. What is flux?
Yes, sir. Number of particle into area.
Ah, right. Per unit incident flux means it is per unit area. Okay. Okay. Anyway, so this is the definition of differential cross section. Okay. Did anyone attended my session for some classes for in the first session, not this session? I mean before November. Actually, I have discussed all the things in the first session. I am just repeating these things. Anyone from the first session before November? I don't know whether.
Sir, I have attended few of them.
Okay, I discussed one of the I think week 6 or 7 in the first session. I discussed the scattering problem in a broad way. Anyway, from
I remember.
okay, fine. Some of the, so I'll be repeating these things anyway for this question, and in the next question also it will be same thing. Okay. Anyway, so what according to a definition, if we want to write the mathematical equation, that is for the differential cross section, that is d sigma d omega is basically 1 by j in, that is the incident flux, times dn d omega. So you can read the statement. It is defined as the number of particles scattered into the solid angle in a direction theta comma phi per unit time per unit incident flux. So mathematically it can be represented like this. Okay. So total cross section is defined as your differential cross section integration over your total solid angle. Solid angle. So it is defined as, so you have to integrate over theta, integrate over phi, d sigma d omega times this d omega, that is sin theta d theta d phi. So sometimes it is asked in the question, if you have spherically symmetric potential, in that case your sigma, that is differential, that is your sigma theta, that is the cross section, will only depend on your theta, not phi. We will have azimuthal symmetry. Okay, because spherical symmetry is basically azimuthal symmetry, right? So total cross section is your, then it will be 2 pi times, because you will not have any dependence on phi. So you will have integration of phi, that is 2 pi, that will give 2 pi. You will have 2 pi times integration 0 to pi times this d sigma d omega times sin theta d theta, and as it is a cross section, so it will have dimension of area. Can anyone say what is the unit of usual unit of scattering cross section used in the experiment? There is some particular name. The unit of,
Bar.
sorry,
Sir, I think bar.
not bar. It is barn.
Okay, 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 sir.
Do you know what's the value of one barn in terms of meter square?
10 की power minus 28.
Right. So that is the, so scattering cross section of atom is that much small. You can imagine 10 to the minus 28 meter square, right? Yeah. Okay. Now coming to the relevant point that is required in our question. So your scattering, so we'll try to calculate the scattering amplitude. That is what we'll know what is scattering amplitude actually. So you have incident wave function, that is the plane wave function moving along the z direction, that is a e to the power k I k naught z, right? Now after scattering, it will be spherically diverging scattered wave, that I have shown in the diagram, right? It will be spherical, it will be scattered in every direction, but the amplitude may not be same in all directions. It will depend on theta comma phi. So we introduce a term f as a function of theta comma phi. It is known as scattering amplitude, because it will tell us what will be the amplitude of the wave after scattering. Will it increase, or sorry, will it, how much will it be increased, or it may decrease because it may gain some energy, right? Or it may lose some energy, right? So this factor will determine your amplitude of the scattered wave. Now for spherically symmetric potential, in the same way, it will not have any phi dependence, it will have any theta dependence. So you can write it as a times f as a function of theta e to the power I k dot r divided by r. Theta is the angle between your incident wave vector and scattered wave vector. Is this clear, this picture? Any confusion about this? Any question?
No, no, sir.
Okay. I think you have read this thing in the scattering chapter. I am just summarizing the things. Okay. Now relation between scattering cross section and scattering amplitude, that we need actually to solve some questions. So in case of inelastic scattering, your scattered wave vector and incident wave vector may not be same. So the relation comes out to be, you can calculate, or you can see any books that calculates these things. In general, if your k and k naught is not same, then d sigma d omega will be k by k naught times mod of f square. But in case of elastic scattering, k and k naught magnitude will be same. So it will cancel out. So it will give directly d sigma d omega, that is differential cross section, equals to mod of f square. So it's the relation between differential cross section and scattering amplitude, right?
Yes, sir.
Okay. Now coming to the first Born approximation, that was our question. So the answer of this question lies in this part. So first born observation says that your scattered wave will be plane wave, and when it can occur, it is very intuitive. That is, when your scattering potential is much weaker, or you have large incident energies of the particles. So how it will affect? It will affect the slight distortion of the incident plane wave. So basically, you can approximate your scattered wave into a plane wave. That's the approximation of first born approximation.
Sir, weak enough like Coulomb potential.
No, Coulomb potential. So you have to see the magnitude of the potential, not like Coulomb potential or Yuka potential or anything else. So you have some energy of the particle, right? You can say some
Yes, sir.
electron volts, and you know the energy scale of the scattering potential. So the ratio should be very less. That's the thing.
Okay, sir.
Okay. Okay. Now, how can we? So, according if we apply the first born approximation, I will not discuss the whole mathematical formulation. I will just tell the final formula which we have to remember exactly. Otherwise, it will be very difficult to solve the questions in time within time. So, in the first born approximation, you will have this formula for the scattering amplitude. This is very easy to remember. Only the prefactor you have to remember. So here some book write it as m, but precisely it is mu, because you have to consider reduced mass. If your scattering mass is very larger, then it converges to mu, right? So essentially, if your scatterer is static, a scatterer is not moving after scattering phenomena, then you can write it as the mass of the incident particle. Otherwise, it will be reduced mass of the both the systems, incident particle and the your scatterer. Okay. So here it will be minus mu by 2 pi h square times e to the power I k minus k naught dot r. Vr is the your scattering potential and the volume element, right? You have to integrate over volume element. Okay. So here we introduce this k minus k naught. Here k is the scattered wave vector and k naught is the incident wave vector. Okay. So k minus k naught as q. So we can find the mod of q. So that will be root over mod of k naught square plus mod of k square minus 2 mod of k naught cos theta. Theta is the angle between your k and k naught. And in case of elastic scattering, most of the problem you will be asked in the case of, if you are not said anything, then you have to consider elastic scattering. Okay. And if it is said in the question, you will be informed in the question if it is in elastic scattering. So mostly it is asked regarding the elastic scattering problem. So then your k naught and k value will be same. So you can just pull out the k outside the root over, then you will find it 2k sin theta by 2. I will not discuss the mathematical part here. I think you will get 1 minus cos theta, that will be 2 sin square theta by 2, and you can just root over this. Okay. So here k minus k naught dot r is q r cos theta, because theta is the angle between your q and r here. Okay. And for spherically symmetric potential, that's the thing, your r vector will be basically r, only depends on the distance between the center and the point of interest, where you are trying to calculate the scattering cross section or scattering any quantity. So then it will be simplified. So it will be like IQR. So this term will be IQR cos theta, and your VR vector will be VR, only depends on the position R, and it will be R square sin theta dr dt d phi. So as it is theta and phi dependent, sorry, so only this quantity is phi dependent. So you can just integrate over phi, that will be 2 pi, and then you can do afterwards that. So I have discussed this thing in the earlier session. I will not discuss much because this part is not related to our question. Anyway, you can just recap these things. You can visit your book and you can see these things. Okay. Anyway, I have already included the slides, so I will discuss these things. Then it will become f as a function of theta, not phi, for spherical symmetric potential. Then you will have e to the power I q r cos theta vr r square sin theta dr d theta d phi. Now d phi integral will give you 2 pi.
Sir, for my side,
Ah,
yes, sir, for my side, this is completed because I know this whole thing.
Okay, anyway, this is the last slide. I want to complete these things as I have started the bound approximation part. Okay.
Yeah.
So and theta, so you have to find this integral. Integration of 0 to pi sine theta e to the power I q r cos theta, right? This is the theta dependent part here. So I will not discuss this calculation. This is a very common calculation we encounter in this type of problem. This integration, it will give you 2 sine q r by q r, this integration. So essentially you will get for spherically symmetric potential, the scattering amplitude will be minus 2 mu by h square q. Q is coming from this part, and you will get the integration r equals to 0 to infinity r sine q r v r dr. Now you will be given in the question the type of potential that depends on the central potential, let's say that is 1 by r square type potential. Then you have to put this here and you have to evaluate the integral over r. So this type of question is asked in the question also. That's why I wanted to discuss this thing. I think no one has doubt. This is totally mathematics involved in this, right?
Yes, sir.
Anyone, any question? Amit, Sejal, Aparna, and whoever else. I can see new faces. Some I am not asking them. Anuj, Shandeep.
No, sir.
Okay,
Clear.
okay, okay. Now, this is the theory part. Okay, so for this question, it was very easy, right? This is the first
Yes,
option.
sir.
But now the second question, which also Harris sent, related to this Born approximation. The question came in the CSA June 2017, 2008 exam 2017. The question is, consider the potential V as a function of R vector is summation over I V naught A cube delta function of R minus Ri. ठीक है, ठीक है. So where Ri are the position vectors of the vertices of a cube of length A centered at the origin, and V naught is the constant. And if V naught A square is very less than h cut square by 2 m, the total scattering cross section in the low energy limit is option A 16 s square times m v naught s square by h square. Option B is 16 s square by pi square times m v naught s square by h square whole square. Option C is 64 s square by pi m v naught s square by h square whole square. And the last option 64 s square by pi square times m v naught s square by h square. Okay. Whatever you need the formulas, I have already discussed in the previous solutions. If you want to see the formula, I can go to the this thing. Please take a note down of this VR. Okay, only you think you need the type of potential in the problem, right? Okay, can anyone say what is the significance of this V naught s square very less than h square by m? Why it is?
Yes, sir.
What is the significance?
Uh, uh, oh,
Can
like
anyone?
weak potential, weak potential.
Yeah. So what does it
Weak
signify
scattering potential.
then?
सर इसका मतलब ये है कि इन्होंने मतलब एनर्जी के कंपेयर में जो पोटेंशियल है वो बहुत कम है तो यहाँ पे
What does it mean?
बॉन्ड
From the first
अप्रोक्सीमेशन
question, yes.
बॉन्ड अप्रोक्स
So that it signifies that you can apply the first bound approximation. So
यस
it is given as a hint in the question. You have to pick the hint from the question, right? Anyway,
यस सर यस सर
so I will go to the formula. So general formula, okay, that is this formula. Here only thing you have to consider m here, because you can see in the options it has been used m, not mu. So only thing you use m instead of mu. Okay. Sometimes it is used as a reduced mass, but here it is used as a scattered sorry, incident mass. Okay. So this is the formula.
Sir,
Yeah.
sir, would you please expand on that a bit? Why is it giving us the energy V naught A square? Why is it giving us the potential strength, which is much less than h cross square by m?
Okay. So here V naught is very less than h cot square by m a square, right? So here
Yes, sir.
A is your length of the cube. So basically the scale, the wave vector scale is your 1 by A or 2 pi by A, right? So this will give you the some kinetic energy, the scale of, I mean, some, not exactly the kinetic energy value, but some idea about the what should the value of the your kinetic energy of your system, the basically incident particle. So that you can understand, right? H cut square by ms square. So this is very greater than your potential, scattering potential. This means your potential is very weak. That's the thing. So
Okay, sir.
basically, it signifies that you have to use the first Born approximation. But at the text of messages, you have to apply the Born approximation because this hint is given in the question. That's the thing. Also, it is said that you have to use the low energy limit, but you will see this will affect your result. I mean, okay, I will not tell much, and I will go to the formula. Okay, if you need this formula, this scattering amplitude formula, because you have to find the scattering amplitude first, right? Then you have to find the what you have to find in the question. I forgot. You have to find the total scattering cross section, right? So then for that, first you have to find the scattering amplitude, then you have to find the differential scattering cross section, which is mod of f square. Then you have to integrate over the solid angle. Then you will get the total scattering cross section. Is it clear? I mean, you got my point, right? There are three steps.
Yes.
Okay, so I'll go to the formula of f, that is scattering amplitude. You have to find it first for this problem, and I hope you have noted your potential. And so basically the picture is you have a cube, there are 8 scatterers on the 8 corners. You can understand from the potential, that is delta function, because only they are located at the corner of the that is the vertices of the cube, right? And the value is V naught AQ. Okay. Okay, so will I go to the formula, this formula? You can note it down, and if you need the question also, please tell me. I will go to the question then. So how are you doing that? Can anyone please tell? Amit, Sejal, anyone? Harish, you have sent the question, so you should try at least.
Yes, sir. We put v value.
Or anything else? So there one more thing you have noticed, it is said in the low energy limit. How will you apply this thing in the solution? Can you tell?
Sir, we can stop at the linear term in the expansion of the exponent.
That you are saying 1 plus I q r, I mean you are saying the exponential expansion.
Yes, sir.
Do you need to consider the
Those
first linear term then? If you have,
Shouldn't we, sir? Because only the quadratic term will go to, tend to 0.
if you need that in this integration, right? So integration of sine theta, that will give non-zero value. If you have q r cos theta, that is sine 2 theta, what will it give? Will it give 0?
yes, sir.
Okay, then you don't have to consider the first linear term also. So basically, basically what I am to say, for the long wavelength limit, actually the question solution is very easy. You have to understand the trick here. So this q value is tends to 0. Why? Your energy is so low, your wave number will tends to 0, because the wavelength is very large, right, for low energy.
Yes, sir.
So you
Yes.
can just it converges to 1, this value. You don't have to do the integration also, sine theta integration. You just put the value q tends to 0, it will be 1, then you have to integrate over only potential. That's the thing. You got my point, my hint, right?
Yes, sir.
Okay. So Sejal, you got my point, right? I mean, you are correct. What you are saying, you will get this. You will end up with the same result, but for the ease of calculation, I just said this. Okay.
Yes, sir, but mostly we do go up to the first
Yeah, I
term,
know, I
so
know, I
that's
know,
why.
I know, I know, I know. But anyway, you will be getting so. Anyway, when you will do that, you have to see the integration. It will give 0 because sometimes we encounter this type of integration sin theta cos theta, right? It will give always 0,
Yes,
0
sir.
to pi.
In this case, it's zero anyway.
Yes, yes, that's the thing.
Sir, what next?
What next means then you have to do this. I have said everything.
सर मैं यहाँ तक पूछ गया मेरा जो वैल्यू आया है -m/2 pi h क्रॉस स्क्वायर
Ha.
v नॉट ए की क्यूब
Just
समेशन
just
आई.
let, just let me check what is the f theta value. Your f theta value. If so, you are saying the scattering amplitude, right?
यस सर.
What is the you are getting? Can you please tell?
-m/2 pi h क्रॉस स्क्वायर इंटू v नॉट ए की क्यूब समेशन ऑफ आई
Okay.
टेल क्यूब आर वेक्टर माइनस आर आई वेक्टर डी की क्यूब आर वेक्टर.
After integration, I am saying, after doing all the integration, you will not have any r dependence term after integration, right? You have to integrate over r 0 to infinity. Okay. Anyone else is trying? So I have simplified these things. So what I'm trying to say, you will have one. You can consider this term one because this is a low energy term. You have to just put the potential here, that is summation over I, where I is 1 to 8 because we have 8 scattered here, right? Yeah, at the 8 vertices. V naught A cube delta R minus R. So basically delta value will be 1 when it will be at the vertex, or otherwise it will be 0. So okay, so just a simple thing, the integration over delta function over the volume is 1, right, this property. Can anyone say yes or no? I mean,
Yes,
Yes,
sir.
sir.
okay, just the
Yes.
integration is also simple, you don't have to, the integration will be 1 and you have to just consider the summation term here. That's the mistake I think you have done, that Harish has done already, and
Yes.
that will make the difference in the answer. The factor, prefactor, what prefactor you will get for the summation. So Amit, what are you doing? I mean, is it understandable?
Yes, sir.
So why are you
I've
stuck?
so I've got the d sigma d omega. Then I'm
D sigma
calculating
d
the
omega,
total scalar.
d sigma d omega you got, right? That is mod of f
Yes.
square you obtained. What is that? Can you please tell me?
So m square by 4 pi square h cut to
Hmm.
the power 4
Hmm.
times v naught square a to the power 6.
Just e to the power 6 you got, v naught squared you got, right?
Yes, sir.
M squared you got, right?
Yes.
And in the denominator, what you got? Can you please tell me?
4 pi square h cut
To the
to the
power
power
4.
4.
Okay. You have done some mistake. In the prefactor, you have done some mistake. Otherwise, every term is okay. That's why you can see. I mean, there are two options with a to the power 6, right? That you can relate to that. But their prefactors are different,
Yes.
right? So, anyway, you have done some
Is
mistake.
it B?
Who is saying B?
Prajwal.
Okay, just hold on. I am to listen from other people. Sometimes this prefactor makes our life difficult.
So it will be 4 pi, not pi square.
4
Uh,
pi square will be
no,
okay. You are talking
I'm
about the
confused now.
differential cross section, right?
Yes.
Okay, that denominator you will have pi square or pi.
I'm confused now.
You check your calculation now. You check your calculation. Don't believe on me. You just see whether you are doing correct the calculation. Here totally it is mathematics. You don't have to worry about the physics in this calculation. You have done the you have applied the concept of physics, the scattering concepts. Now you have to do the mathematics. That's the thing. And I don't think this is too difficult calculation. I mean, I have solved this and I can see, I mean, that is not matching with your value. That's why I'm saying you are wrong. I'll I'll just check here. No, think I have done it correctly.
Sir, since we want pi square h cross 4 in the denominator, only option B matches with it.
Okay, let me see. Let me tell. Option B is not correct answer. That's the beauty of the NET exam. You will see something, you will guess, but it will not be correct. They manipulate the options in such a way student will get confused. Option B is not correct. Let me tell you.
So then only option C is correct.
But you are not. Option C is why it is correct. Yes, option
Means
C. Option
the
C is
first
correct
one.
because I have already said the option B is not. But most of the students will do the option B, right? Because you,
Yes, sir.
if you have done that in that way. Okay. Anyway, I'll go to the solution part. You just see. Anyway, you don't do it like this in the exam. Sometimes it is helpful to cut the options, but you should know how to solve this properly. That will be helpful in your future also, actually, if you want to do some theoretical calculations or something, right? Okay. Anyway, I'll so given scattered potential is this here. So this is given in the question. I will not repeat this thing. So basically, the picture is you have a cube, you have 8 scatter at the vertices, right? And the scattering potential is much weaker than the energy of the incoming scattered particles. So basically, this signifies that, and this signifies that you have to apply the first Born approximation. So from first, sorry, for it is S is missing. I have to check this. Okay, first Born approximation. Uh, the scattering amplitude is given by this. I have already discussed. At the low edge limit, you can consider this q tends to 0, or you can what Sejal said. You can just expand this, or you can end up in that expansion into the first linear term, but it will not change your result. So basically, it will be 1. Okay, this term will be 1. You can consider this. So you have this integration minus m by 2 pi h car square integration via dq bar. So here people will do mistake. I think Amit has done same mistake because the prefactor was different for him. So you have summation over I equals to 8 is equal to 1 to 8, and you have v naught a cube and integration over your delta function. This integration will give you 1, but you have summation over I equals to 1 to 8 because of 8 scatter. So basically this summation will give you 8 here. Okay. So you will have 8 times m by 2 pi h car square v naught a cube. So this will give you minus 4 m v naught a cube by pi h car square. Okay. Amit, is it clear?
Yes, sir.
सर
So
सर ये इंटीग्रेशन वन आ गया, इसका समेशन करेंगे 1 से लेकर 8 तक, तो ये 8 आंसर देगा, राइट?
8 होगा, हाँ. So 8 by 2 is 4. That's why I'm getting the 4 and everything is same. M v naught a cube by pi h square.
8 क्यों होगा सर?
8 scatter is there and it will give you 1. So summation over I equals to 1 to 8, and inside this is you have 1 only. So 8 times 1, right? You are summing 1 8 times.
ओके सर.
Got it?
यस सर.
Okay. Then it's simple. Just do the differential cross section. That's the whole square of this. It will give you 16 a square by pi square m v naught a square by h square square. So it is given in your option, I think, right? This option.
Sir.
So, but you have been said that is your total cross section. So what you have to do? You have to just integrate over d omega. So basically the integration as the this if sigma theta is independent of theta and phi, so the calculation will be much easier. So basically your solid angle integration will give you what it will give? It will give 4 pi, right? Only the integration over solid angle. So total solid angle is 4 pi, right? Can you
Yes,
say?
sir.
Yes,
So,
sir.
so you don't have to do this integration also. You can just multiply 4 pi with this because this is independent of theta and phi, right? So it will give you 64 a square by pi mv naught a square by h square whole square. This is option C. Is it clear, Harish?
Yes, sir, very clear.
Very clear, right? Amit, Sejal,
Yeah.
you got the Amit. You understand your mistake where you did the mistake.
Yes, sir. Yes, sir, I forgot the summation.
Summation. Yeah, I knew that
सर
most of the people will do mistake there.
सर मान लीजिए हमें बोर्न अप्रोक्सीमेशन पे कोई क्वेश्चन आता है
हाँ हाँ.
तो जनरली हम टोटल स्कैटरिंग पूछता है तो हम डायरेक्टली क्या करते हैं टोटल स्कैटरिंग वाला ही फॉर्मूला यूज करते हैं तो सर
See,
ये जी
if
रहता
you
है
if you okay, if you can remember the formula directly and that is applicable to the question, then it's good. You can apply directly. But most of the time, you have to apply the scattering amplitude. I think I have seen the questions. Most of the questions we encounter, we should know this formula at least.
युकावा पोटेंशियल समटाइम्स या
That's the thing. So you can start from this and okay. Whenever you need to apply the total cross section directly, you can apply. That's the thing. But in this case, you have to apply this thing, right? Because the potential is different here. So you should start from the scratch, right?
या
Okay, everything is clear to everyone, or any doubts about this question?
No, sir.
नो सर
Okay. And also this question was a little bit lengthy in gate. Usually this type of not too much lengthy because this question involves from this step and this integration. I have seen 4 steps. You can do it by 2 steps because you can just see the delta function, right? This question was very I think in NET this question contains 5 marks. I don't know. I forgot to see 5 or 3 marks. What was the marks of this question, Harish?
सर आई डोंट नो
I forgot. Is it 5 marks question or 3 marks question? I forgot. I didn't see. Anyway, if it is also 2 marks question, then it's fine. I mean, you can do it within. If you know the procedure, then you can do it within 1 minute. This solution. You have to do only the integration and square of this. Okay. Anyway, the answer is C for this question. Now coming to the last question of this doubt clearing session. So this question was sent by Sejal. Okay, this question came in the CSN NET 2022, and the topic is the EM theory, or basically this is magnetostatics. So okay, the question is two parallel conducting rings, both of radius r, are separated by a distance r. Okay, so radius is also r, separated by r. The planes of the rings are perpendicular to the joining their centers, which is taken to be x-axis. Okay, and current is passing in the same direction on the both the coil. Okay, so here it is, if the rings carry same current I along the same direction, the magnitude of the magnetic field along the x-axis is best represented by, there are 4 options given. The variation of magnetic field with respect to the distance x from this point O along the x-axis, right? So there are 4 options. So you have to choose the correct plot in this case. Okay. So is the question is clear to everyone?
Yes.
Okay, Sejal, you tried that question after that. I mean, you sent me 1 week back, but did you get? I mean, I saw your incomplete solution. You sent me a photo. In that, I think you have written the wrong formula in terms of coordinates. I have seen. I will not share here, but I have seen you have done something wrong in there. Also, the approach will be little bit different because you are correct that you can't find the direct extrema point, the maxima minima point here directly, because if you do the differentiation, then it will be difficult. Right, Sejal? Your concern was that?
Sir, I was getting an extremal point. That was my concern, that we are not supposed to get if that answer is to match with the answer key.
Sorry, I didn't get your point. Can you please repeat your statement?
Sir, so according to me, the answer was ID number 142,
Hmm.
and I was getting an extremal point. in accordance with this. But the right answer is option ID for 141, and so we shouldn't have got an extremal point.
Yes, the right option is option 1. That's correct, and that is obvious. That I'll tell you
So
why.
yeah, that was my concern. Why am I getting it when it's not
You are
supposed to
getting
be
some
there?
external point from your yeah.
Yes, sir.
Oh, then I should have seen your seen. Okay, I will not approach in that way. Anyway, we can discuss this. Okay, okay. Anyone want to say? Okay, so I have told the answer already. That is option A. Okay. So anyway, so you guys want me to discuss this problem, this type of problem in detail. So I have prepared some notes about this, and this is very well known problem. Can you not say what which is this system is known and with this some particular name, and it is important this type of
Helmholtz
system.
coil.
Yes, why it is important? Can you say?
So to
Producer.
find ESR, we need that.
Sorry for.
For ESR experiments, we need the
For
Helmholtz
ESR,
coil.
you need Hema's coil, but for ESR, why do you need that in ESR or anything? What property you use? What property of the Hema's coil you use in that some experiment? That ESR. You are saying ESR means your which resonance is this? That is full form of that?
I forgot, sir.
Yes,
Sorry.
yes, sir. Electron some resonance. I forgot the. Have did the experiment in my IIT Kanpur. I forgot the name. Oh my god, long time back. Okay. Anyway, but what property you use? Why it is used? Not only ASR. This type of system is used
So,
in most of the lots of system. Do you know why?
so it has
So the
something to
full
deal
form
with
is
the
electron
spin.
spin
Sorry,
Means
resonance.
sorry. Electron spin resonance. Sorry, I forgot. Oh, it was easy. Yeah. Sorry.
so it has something to do with the spin. I forgot it.
No, 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 no. Hamer's coil is used in lots of equipments actually. That there is some reason.
Produce a uniform magnetic field.
Yes, exactly. At the center, at the near about some region at the center, it will produce uniform magnetic field. So it is difficult to produce uniform magnetic field, you know. But using this kind of system, you can produce the uniform. And in for ESR, you need a cyclotron path of the electron, and your magnetic field should be uniform, right, all over the region of experiment. That's why you use the
Yes.
Hamel's coil. So there are certain condition how you can construct the Hamel's coil. You can't only put this to coil and you can get the uniform magnetic field. You want me to discuss this thing? I think you have read this thing in your magnetostatics, but I think, and from that aspect, I will be answering this question, because if you know, then you don't have to do in mathematical calculation also. If you know the informations, if you know about the Helmholtz coil, then you should know the plot of the B versus X, obviously. But if you don't know, I can discuss these things. Okay, okay. So okay, I'll do it, tell it very quickly, and you can ask me, you can stop me in between that. Two parallel conductor rings having R separated by a distance R, right? The planes of the rings are perpendicular to the line joining their centers. Both the rings carry the same current I along the same direction. We have to find the plot of magnitude of the magnetic field as a function of x. Okay, so this is our system. Now, what is Helmholtz coils actually? When it is called Helmholtz coils, okay. So for this two coil system, where two similar coils are placed parallel to each other with their centers at a distance apart equal to the radius. So basically, their separation should be equal to their radius. Then there will be uniform magnetic field midway. Midway means this at the center between these two identical coaxial circular coils. This is known as Helmholtz coils. So the condition is that to get the uniform magnetic field, you have to separate these two parallel coils that should be equal to your radius of the coil. And why it is coming, why it is so, we can see the mathematics. I will just discuss the mathematics there. Okay, first let us consider two coils. Okay, having radius r, they are separated by a distance r d. We are not talking about the distance equal to the radius. Now we want the magnetic field to be uniform in the region surrounding by this surrounding the midpoint. Okay, So the resultant magnetic field at a distance, so so you have to know the formula for a current conducting loop at a distance x from the center. That will be your mu naught I r square by 2 divided by r square plus x square whole to the power 3 by 2, right. So now your origin is here, right. So you have to modify your formula according to that, right. So for this coil 1 at this point P at a distance x from this x, so it will be mu naught, so it will be mu naught I by 2 times r square by r square plus d by 2 plus x whole square to the power 3 by 2. Is it clear? This why this is coming d by 2 plus x?
Yes, sir.
Because from here the distance is d by 2 and here it is x at the point P. We are trying to calculate the resultant magnetic field at point P. Okay.
सर डायरेक्शन समझ में नहीं आई.
डायरेक्शन समझ में नहीं आया.
Yes sir.
So direction would be along x direction, because you just apply your right hand thumb rule, you know, right.
सर ये माइनस एक्स पे जा रही है.
Why minus x पे? Oh अच्छा, I think the picture seems to be okay. So current is going this direction, not I mean coil. Okay, uh, the picture looks like this. Okay, let me go to this picture. Can you understand this picture? From this way it should be along x direction. It doesn't matter if it is minus x or x, okay. But for my case, what I consider, this is anti-clockwise rotation, so that's why it along x direction, okay. Did you get my point?
Yes sir.
If it is anti-clockwise, then it will be x direction. I have considered, so picture seems to be it is either clockwise and it is confusing little bit, right. But anyway, that will not affect your result. Anyway, it will be both readings will have along x direction or minus x direction, right, because current is in the same direction. Fine.
Yes sir.
Okay. So for this coil, it will be r square by r square plus d by 2 minus x whole square 3 by 2. Now let us consider a point P at a small distance x from the center or O. So this is the point which has the distance x from O, which is very small compared to your radius of your coil. Resultant magnetic field will be uniform about the midpoint if your magnetic field will not have any spatial variation. That is called uniform magnetic field, right. It will not vary with spatial translation, right. So you will have dB dx around the point O, it should be 0. So if you just differentiate that, I will not go to the brief calculation. You have to do the differentiation of these two terms. Essentially you will end up with this term. You can't solve this directly for x, okay. So from here you will get this d by 2 plus x by d by 2 minus x to the this term to the power 5 by 2. Now x is very close to origin, right. So your x is very less than d by 2. So x square term can be neglected. So I have neglected x square term. Then I have rearranged it as 1 plus xd by r square plus d square by 4 divided by 1 minus xd by r square d square by 4 to the power 5 by 2. Now you just apply binomial theorem and consider the first term. So it will be 1 plus 5xd by. So you have to just multiply 5 by 2 with this term, multiply 5 by 2 with this term. Then you just do some algebra, that is plus 1 minus 1. So you will get, you just add up this term and subtract this d by 2 plus x minus d by 2 minus x.
Component to dividend.
Yes, exactly. That's the thing. So that is d by 2x and you will get 2 by 5xd by r square plus d by square. So essentially we will end up with d equals to what? So this is the condition how we get for this two coil system. When we will get the uniform magnetic field near about the center, that condition should be d equals to what? So this is actually given in your question. If you know this fact, then you don't have to go you don't have to do this all these things, okay. And I mean something you should remember, the entrance exam, I mean want students to recall some things, not everything you have to do some scratches, right. So this is the thing. Now near the midpoint the magnetic field will be uniform and its magnitude is, you have to put d that d equal sorry
सर वॉइस नहीं आ रही है.
huh sorry Hello, hello.
So no, it is clearly audible, sir.
Okay. So now for at the midpoint, you have to put your x equals to 0 and d equals to r. That is also given in the question, and for Helmholtz coils, it is d equals to r. So you put that, then you will get it mu naught I times r square. So here it will be 2 here, and you will get same thing. So 2 times r square by 5 r square by 4 to the power 3 by 2, right? You will get 8 mu naught I by 5 root 5 r. So if you just do it 5 root 5 by 8, it will come out to be 1.4. So you can see this is greater than B, the magnetic field at the center of the single coil, right? Single coil is mu naught I by 2r, right? Is it correct?
Yes, sir.
So resultant magnetic field for this Helmholtz coil at the center is greater than your single coil magnetic field at the center, right? Okay. Now most of the books discuss these things about Helmholtz coil. So if you just even if you know the single coil result, you don't have to go for the calculations also. What is that? For Helmholtz coil, you know that it will be uniform near about the origin, but it will not be uniform all over the distance, right? Because the limitation is that. So if you see the coil 1 picture, that magnetic field, then it will decay like this, right? This is a even function of x, right? And coil 2, it will be like this. So if you just add up these things, so what will happen in this central region, you know that it is higher than this value because it is mu naught I by 2r and this is mu naught I by 1.4. So you have to start from that, but as you go far away from the midpoint, the effect of this, obviously the value will be little bit larger than the your single coil, but nature will be same because the effect of this coil here at this larger distance will be minimal, right? And it will decrease as you go from the midpoint. So this plot should be this, not whatever you are saying, Sejal, the second option, right?
Yes, sir.
So second option cannot be correct for Helmholtz coil for sure. It will not be. So what does it mean? In the second option, it was uniform all over the region, right? And
So above this.
oh, sorry, it's not second option, third option. Yeah. Oh, you are saying for second option that this
Yes,
option,
sir.
that is the anyway it will not be correct. That is the anyway it will, if you draw the picture of these two things, interference, I mean, or you are overlapping two function, and you will get this nature, that is not possible anyway. I was concerning you said this option. Okay, sorry, I misunderstood your question. Okay, fine. Uh,
So, sir, basically
hmm,
the approach should be to plot the individual
yes,
plots and then sum them up.
sum them up, but then there is also a confusion. So I there will be confusion in between these two options. Okay, let me tell you. If you don't know about the Helmholtz coil, then you will be confused in between this and this, right? You can sometime you have studied that interference overlapping two wave, right? That relay condition of resolution, two packets are overlapped, then you may have minima here, you may have maxima here, right? You read that thing in the interference chapter when you are having two wave packets overlapping that. So basically you may have maxima or minima here. So these two plots are plausible plots if you don't know anything about this thing, but you know the initial concepts. But this you will be correct because you will have maxima at the center. Okay,
And so why not C?
why not 3? This is signifying that you have uniform magnetic field all over the region from minus r by 2 to plus r by 2. It is not possible because you have the uniform region only near the midpoint. We have already discussed x is very, very less than d. That's the condition. From that condition, you are getting d equals to r. That's the thing for Helmholtz coil. That's why when we do the experiment ESR, or I have used mutual coil inductance, okay, For that we keep our sample, we try to keep the sample at the midpoint. Okay, that's the reason.
Yes.
That's the reason to get the uniform magnetic field, because your sample has certain dimension, right? Certain, it's not a point object, and if your dimension of the sample is not lying in the region of uniformity, suppose, say for example, for this system, I don't know, I am saying, I am telling you the example. Suppose within within 10 nanometer, for plus 5 minus 5 nanometer, in this region you have uniform magnetic field that is not varying within varying spatially. It's a fixed value. If your sample size is 20 nanometer, if you place at the uh, center, then your sample is not totally in the uniform region, right? Or anyway,
Yes.
if you put your, if you have 5 nanometer sample, but if you put your sample at 5 nanometer from the midpoint, then obviously your sample is not in the uniform region. That's why there are lots of things to calibrate in this kind of system. When you start to use the ESR or mutual conductance, we use, and lots of things. I think magnetic field dependent XRD also uses this kind of coil. This is a very well known system people use from the past few decades. Okay, so these are the things we have to do with the experiment, but this is the initial theory for this to produce the uniform magnetic field, and that's the condition. So if it is so, if the third option is correct, then it will be a great achievement. You are getting a uniform magnetic field over few meters actually, right? But
Yes, sir.
it's not true for this kind of system, and that condition I have already shown you, right? Why it is not true. So I thought Sejal was confused between two. So okay, you were saying this option, this is single coil plot, not two coil. Okay, Sejal.
Okay, sir. And sir,
Yeah.
what argument did you give for the fourth one?
Fourth one, okay. Fourth one, for that I have calculated the uh, this this one. So this at the midpoint, the value is greater than it at the center of single coil, right? So okay, I'll go to the options again. Okay, so here at the midpoint, it should be greater than. So this is the center of the your single coil, right? Minus R by 2 plus R by 2.
Yes, sir.
So at the midpoint, it is getting, you are seeing that the value is larger than your single coil. The, I mean, single coil value, right?
Mm.
So it should be greater than
Yes.
that, your plot. That's why I said that. You got my
Okay,
point,
sir.
right? So I thought
Yes,
you
sir.
will be confused between this plot or this plot. But okay, anyway, there are lots of confusion may occur, but I think it should be clear now.
Yes, sir. My reasoning for the second one was actually that because we have two coils and
Mm-hmm.
both of them have current in the same direction.
Mm-hmm.
So the point that was constantly occurring to me is that at the center, both of them will contribute, and so the magnetic field should just peak at the center and fall towards the sides. So that
Yeah,
was
it
the
will
line
fall.
of thought.
It will fall, but not in this way. In this way,
Yeah, yeah, yeah.
that's the thing. Your logic is correct. Your logic is correct, but the what we, this in between this option, yeah. So your, I understood your confusion right now. So okay, but the nature of the plot will be this, not this. Okay, and
So
also
what's the value at the midpoint?
that is mu naught I by 1.4 r approximately.
सर इसमें थर्ड ऑप्शन सही है क्या?
Huh?
सर कौन सा ऑप्शन सही है इसमें से?
Option A, first option. What plot
Yeah.
is this? This now? I mean, my drawing is not so good. I tried to draw it properly. It should be symmetric about this center, but anyway, option A is correct. So you can see, right? There are two plots and two functions are like this. This will be same, although plots are not same. They should be identical because they are identical coil. One is maximum at minus r by 2, one is maximum r by 2. So when you will add up, but we have calculated at the center it is maximum than this value, right? This is mu naught I by 2. So it will fall down like this. As you go at larger distance, it will follow this nature, because the contribution of this coil at here will be much larger, because it's a 1 by r cube nature, right? It will decay like this, right? Not 1 by r cube, it's a 1 by r actually, dimensionally. Yeah. Is it okay? Any confusion about this?
No, sir.
Okay, there are lots of things. I mean, I was also getting confused, but I tried to tell this properly. Anyway, I think it will be helpful for you. And okay, anyway, so option A is correct for this question. Okay, and please practice much so that you can remember something. So you can remember these things so that you don't spend on the basic part when solving the question. If you can remember these things, then you can easily solve this. I mean, for this question, if you read this, then you don't have to go for the calculation. You can just see the options and you can tick the options, right? You have to just check that. I mean, you have to identify this is the Helmholtz coil system, whether the distance between this is coil and equal to the radius of the coil. You have to identify this thing in some problem. This kind of thing will help you in solving the problems, right?
Sure, sir.
Yes, sir.
Yeah. Okay. So
So had the distance not been same,
not being same, then I have not calculated the plot nature will be same, but what will happen here, you can see the flat part, right? That will
yes.
be like this. This is a parabolic type, but not exactly flat at the center. That's the thing will happen. You can see your plotting. I mean, you can.
Sir,
Uh,
if it is larger than the R value, then it should be fourth option.
you're Are you sure?
Yes, sir. Because
Then I will check by plotting this, or I can do the calculation. I think what I remembered, it should be like parabolic. Anyway, I'll check. Okay.
if it is getting separated, the coils are getting separated, then the it should dip down the.
Actually, it should depend. It should depend how much. What is the distance between them, right?
Yes,
It should depend, because if it is less than your r, then it should be maximum here, or otherwise it will be d. I think so. Yeah, yeah. I think so. I think so. Because if it much closer, then it should be. I mean, at the center, it will be much larger, right? But when your distance is greater than r, I think it will become like this. I mean, it start to deviate like this, right? Yeah, yeah,
yes,
yes. You are correct. You are correct. Yeah, it depends on the condition. So distance is less than r or greater than r, right? But you will not get the uniformity for sure. Anyway, Sejal,
Sir, if
yeah,
sir, if you can spare just 2 more minutes, can I
yeah,
share
yeah,
my screen?
yeah,
Okay.
yeah. So I'll. Okay. Anyway, I am done with this, and now Sejal want to share the screen. Okay, just give me a minute. Sejal.
Sir, have you uploaded previous session?
हाँ.
सर इससे पिछले का सेशन आपने अपलोड कर दिया?
सब कर दिया. देखो, यूट्यूब चैनल फॉलो करो मेरा.
ये सर आप मैंने चेक किया था 5-6 दिन
ओह
पहले.
नहीं, वो थोड़ा लेट हो गया था, मैं थोड़ा काम में बिजी था, बट कर दिया 2 दिन पहले, तो कर 1 दिन या 2 दिन पहले किया मैं थोड़ा बाहर था, तो इसलिए कर नहीं पाया.
So is it visible?
No, it's not visible. I can't see anything. I can see my screen only.
Okay.
Anyone can, I don't know, is it only my
No, sir.
problem? Okay.
no, sir.
Okay.
Also,
Yeah, but it is very small. Now I can see. Yeah. Okay.
sir, so last time, or maybe before that, we discussed this question. My doubt is that the Hamiltonian in when a charge or maybe a spin, anything carrying a spin is present in magnetic field, the Hamiltonian is given by mu dot B. So here we have it in this form minus gamma B Sy, which indicates that the magnetic field should have been in the y direction. But in
Okay.
the solution, we are writing the final or time evolved wave function in terms of the wave functions of the along the z direction. So basically,
Can I share my screen so that I can see the full solution? Okay, you can.
yes,
I
sir.
understood the question. I'll just share my screen so that I have to see the solution then. I mean, okay, just give me a moment. I will open the PPT now. Okay, just 1 minute. So this was which week question? Can you please tell me? Last week?
So last week.
Okay,
So last week actually.
last week. There is a week
Okay.
7.
Yes, sir. Yes.
Let me check then. This was just question, right? Okay, yeah, week 7. Yeah, I got the point. Got the PPT. Just okay. Okay, I found that. Okay, I will share my screen. This was the question, right?
Yes.
Okay. So, now Sejal, can you please repeat
Yes,
your
sir.
confusion now? For the
So the confusion is that the magnetic field is in the y direction. So how can we get a final wave function in which, I mean, the amplitudes are distributed among the sz wave functions? I mean, plus and minus wave functions of the sz operator. I mean,
no, no, no,
the
no,
spin should not
no.
be along the z at all in the final state, in the z direction at all. It should only be along the y direction, right?
Okay.
ये एक्स में भी हो सकता है.
Just 1 minute. Let me check. No, see, this is not actually exactly aligning along the z direction. There's a combination of plus and minus state. This is a mixed state. This is not exactly z direction state, right? And the coefficients are different here. This is not exactly along the z direction because initially it was along z direction. It is said in the question, right?
Yes, sir.
But you can see this is not a z component. I mean z component of spin. There's a combination of plus and minus, and with the different coefficient. That is mixture of. You can represent it as x y component also. Because if you want to plus state can be represented as this is 1 0, and what is the state for y? That is 1 by root 2 times 1 plus minus 1, right?
Yes.
You can easily represent that in terms of sy eigenfunction, right? Plus minus state.
Yes. Just like SG experiment.
So it's so this is not like that key you are getting plus and minus state combination that means that you are getting z direction component.
एक्स में भी हो सकता है
Yes.
सर.
But
Sejal?
sir, that
Yeah.
leaves us with an uncertainty, right? Because we want
Yeah.
to be sure that it's in the y direction, right?
Yes, that depends on your measurement. Whatever measurement you want to do, that expectation value will get. If you want to you can evaluate the sy I mean this component also. So what we are doing here, just let me check from the initial. Just give me a moment. Initial sy. Okay, this Hamiltonian is sy. So we are getting sy. Okay. We are measuring SZ. That's why we are getting this. Now tell me what's the confusion? You should get.
So the confusion is that uh, these plus and minus states indicate that the spin is either in the along the plus z direction or in the z direction, not in the y direction, right?
No, 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 no. See, final state is combination of with this, right? When you are operating SZ, then so find what is the final state. Final state is this, right?
Yes.
This doesn't mean you have only z direction component. This is a mixture of z plus and minus. This will give you you can convert it into your eigenfunction of sy also, right? Actually it can be done. You can you not do and tell me what's the answer? I can also do that. with you? So just convert it in terms of, let's say, the just give me one moment, I will check. So what's the plus state for y? That is, can you say 1 by root 2 1 1, right?
So 1 plus minus iota.
Oh, sorry, 1 plus minus iota. So 1
Yes, sir.
I, 1 minus I. Let me check. 1 minus iota. 1 minus 1, that is that comes for Sx, right?
Yes, sir.
Okay. I can
HZ
Yes, sir.
1 minus 1.
SZ. SZ is 1 0.
Oh, yes.
Yeah.
SX is 1 minus 1.
Hmm. Right. So let me check one thing. So basically, your plus state along y is 1 by root 2 times your plus state of z plus iota times, just give me a minute. I think I am running off battery. Just I have to connect the battery. Just give me a moment. I am connecting the charger. Otherwise, it will be turned off. Okay. Just wait for 1 minute. Am I audible?
Yes, sir.
Okay. So, okay, what I was doing, okay. So basically, your eigenstate of Sy, that is upspin state, is 1 by root 2 times plus state plus iota minus state. That is, plus minus is basically your z direction I am talking about, and if I subscript it as y, that means eigenfunction of Sy, right? So you understood that, right?
Yes, sir.
So similarly, you can do minus of y is 1 by root 2 times plus of z minus iota minus z, right? Now you can find plus z in terms of plus y and minus y. So you can just that's a combination of these things. That doesn't mean it's a, you understood my point, right? You can write it in terms of eigenstate of sy also, right?
Right, sir.
Because they are correlated, the states are correlated. There's a, because superposition of two states is that is jet, the eigenfunction of the is jet is basically giving you the sy and sx eigenfunctions. That's the thing here, don't confused with that, right?
But, sir, as far as I understood it, when we write an amplitude with a wave function, we clearly mean no that this is the probability of getting this particular wave function. We don't say that if it's a
Oh, you are
superposition in
saying
Z,
that
then
you are here, you are talking about the probability of to get minus h cut by 2 upon measurement of s jet, you are talking about this.
no, sir. Sir, the fact that it's a superposition in plus and minus states of SZ,
Haha.
it cannot directly mean that if just because it's a superposition, it can take on SY. Had it just been only a single plus, even that is not allowed, right?
Hmm. I still not getting your point, because this doesn't mean you okay. Uh, mm, so this means you have combination of plus and minus state, obvious. That is the eigenfunctions of Hz. but their amplitudes are different, and the combination may give you some different state that is not along that is not the that is not directly connected to your eigenfunctions of sz, but that may give you some other direction, not exactly y, not exactly z, not exactly x. That's the thing I can understand from here, and that is happening here. Because if I just convert, okay, let me check one thing, just give me a moment. I will do one thing, that is, if I add up these things, then plus y plus minus y by root 2, okay, and this is minus z is plus y. If you do these things, minus 2 iota, so root 2 by root 2, acha. Oh, sorry, so this will be minus y by iota root 2. So if you just write it like this, then it will be plus sine omega t by 2 minus I omega t by 2. But I don't see any problem, Sejal. I mean, there is a you can you simplify your statement? I mean, I can't, I am not getting your confusion. That's the thing. And I can't see any problem here. I mean,
So
yeah.
maybe then what you're saying is, I mean, so basically these Z states can be converted into X or Y. That is
Yes,
the point.
yes, that's the point. Because x and y component are basically superposition of z state. That's the thing.
So
This last
actually
point
we
I think I'm having a problem with.
Sorry. Yeah. Who is telling? I
So actually we cannot measure the whole spin thing as we
Right.
can just measure any
Any
component.
components.
So
That's the thing. Yeah.
so it depends on our measurement that what is the operator we are using. So we will either get sz or sx or sy. If we are
Yes.
getting sx, then sz and sy will vanish,
Yes.
uh, so on.
Yes. Yes.
So
Exactly.
there is still a component, but as we are only measuring in one direction, then the others will become zero.
Basically, what will happen, Sejal, let me tell you. So, your Hamiltonian contains the SY operator, but initially your system was along Z direction, right? So, what it will happen, your electron spin start to rotate along that Z direction, and it will have some Y component, it will have some Z component and X component. So, basically, it will cover a cone type of thing, right? So it is a mixture of states, your sx, xy, and sz states. Yeah, I have to check whether it has sx expectation value. Okay, let me do one thing. If you have plus state, if you operate sx, what will happen? Can anyone say what will happen if you operate sx or sy? Calculate quickly. I think you will get 0, because let me check. Okay, you understood my question, right? You have psi t is this cos omega t by 2. Sejal, you got my point? Can you just do that?
Okay, sir.
Okay, just check whether sy operating on psi t and sx operating on psi t, what it is giving. Okay, I am also doing.
Yes, sir.
Let me check. Okay, so so if you consider plus y, then it will be plus minus by 2, and your minus y will be plus minus by root 2 I. Okay, then your psi t can be written as it will be plus, so 1 by root 2 plus minus I. So sine cos omega t by 2 plus sine omega t by 2. Iota will come once. Plus state plus y state actually. And it will be minus of the 1 by root 2 cos omega t by 2 minus iota sine omega t by 2 minus y state. Okay, fine. Then it will come h cut by 2 minus expectation value will be 1 by 2 1 by 2, that is same, probability is same. Yeah, that's the thing that I wanted to check. See, when you will measure the SY, okay, are you hearing,
Yes, sir,
Sujit?
yes.
Then you will get the probability half of, right, plus and minus.
Okay.
So I am getting the psi t in terms of y component of wave function. Then it is 1 by root 2 times cos omega t by 2 plus iota sin omega t by 2 times the plus spin, that is y, that is here plus spin I am meaning I refer to the plus state of y component, and one and other term will be 1 by root 2 cos omega t by 2 minus iota sin omega t by 2 minus state of y. So if you mod square both the terms coefficient, then it will be 1 by 2, right? Because cos omega 2 by 2 plus sin omega 2 or cos omega 2 minus sin omega 2, that will be same. So then you are getting the probability same half of, then I think that is obvious because you are applying your magnetic field and basically your Hamiltonian is along the y direction now. So, but when you are doing the jet component, then it is time dependent basically. But y component is not time dependent at all, right?
Mm.
So basically, if you see that you have read the Larmor precision, right? Magnetic field.
Yes, yes.
So that is where that if you just read that part, you will understand why this happens and how time I mean time evolves. The wave function, how it evolves. I think in the Gasowadics book it has been described in a great way. You can follow that. Okay, you will understand. I think your confusion will be cleared then. Maybe I have not read that thing for a long time, but it's not too difficult to understand. If you read that, I think you will understand these things. Okay.
Okay, sir.
Okay. Yeah, I also have done something which I have not done for last 2-3 years. Yeah, now I got it. Okay. Okay, also S6 I think you will get for S6 I have to calculate, I don't know. Okay, I have done SY. Okay, fine. I hope I tried to clear your doubt, and please, if you have any confusion, you can send me a mail. Okay, then I can recheck these things.
Okay, sir. I'll read and revert.
Yeah, please try to understand yourself by doing, I mean, just try to find the S6 and SY, how you are what you are getting, then try to understand from that. So basically, you are changing the basis from Z basis to you are changing the Y basis. Then for S6, you have to change it to X basis, right?
Right, sir.
Yeah. So just do that and operate the S6 operator for X basis, Y operator Y basis. Then try to convince yourself. And why what you are getting the probabilities, is it, are you getting convinced with that? And if you are not, you can send me a mail why you are not convinced with that, then I can think about this. Okay.
Okay, sir.
Okay, fine. Okay, so I think, oh, this was the last. Okay, so I think I already said I'll take, it will take more than 2 hours. Already it is 2.5 hours. So thank you everyone, and I think we will have one more class. I don't know, NPL team will inform me. Anyway, you can be get in touch with me by mail. Okay, you can send me a mail. I'll try to reply as soon as possible after getting the mail. I wish you all the best for your exam.
Thank you so much, sir.
Yeah. Okay. Anything else you want to know from me? Anything else? Anything about exams? Also, the exam pattern is same. Like I don't know. I don't have any idea. Anything changes happen?
So, minimum how many subjects we should cover?
Okay. Ideally, you should cover everything to attend full question. Okay.
But that is not possible actually, sir.
Okay. So majorly you should, so see, questions will be all get question will cover all the topics. That's true. Okay. You will get minimum one question from one topic. That's the obvious, right? So what
Yes.
from my experience, you should be well prepared with quantum mechanics. I think everything is you have to prepare anyway. I am just telling the chapters preferably from for my case. Then quantum mechanics, uh, electrodynamics, that includes electrostatics, electromagnetism, everything. That's the thing. Electromagnetism. You will get most of the. I think minimum three four or more than that from that topic. Quantum mechanics and quantum statistics, because sometimes the questions are mixed up with quantum mechanics and statistics. Some off topics question can be asked. I have seen really laser type of question has been asked. I think I have discussed one classes laser chapter. Sometimes Raman spectroscopy, but these were off topic. Sometimes no question has been asked from Raman spectroscopy, but from spectroscopy, that is dipole transition, magnetic transition, this question has been asked almost every year, one or two question. You can just have the idea how their state the transition happens, what's the selection rules, or so this type of question has been asked. So these are the little bit off topic. This spectroscopy part you can leave if you are not comfortable with that. Okay, then you can miss 2 3 questions, but I think you will not and hardly we can attend all the questions within 3 hours. I mean, you should thermodynamics so obvious. Thermodynamics, statistical mechanics, quantum mechanics, electrodynamics, and mixture of quantum mechanics and statistical mechanics. And what else? Mathematical
Math.
physics. I was not so comfortable with mathematical physics. I was little bit weak at that time, so I covered but was not comfortable with that. But anyway, Fourier series, these are okay. This we can attend. I mean, this is easily understandable. But uh, the complex part, I was not comfortable at, frankly speaking, at that time. Uh, Apart from that, what else? What chapters? What topics are there?
Classical.
Oh, classical mechanics, I think you can do. That's a pendulum problem and any problem that you are doing from the BSc. You should. I have not practiced at all. I have just what questions. I didn't remember what I have attended that time, but I have not worried. I was not worried about that. But it's classical
STR, one question is fixed, one or two questions
yes,
per
one
year.
questions Poisson, Black and Lagrangian, so we'll ask for sure. One or two questions from Hamiltonian part, right? And also some that I don't know this type of question, pulley, that inclination, the ball is rolling. This type of question is asked or not. I don't know. I have not seen for a long time the gate questions. I mean, at least 2021, 2022, I didn't see any question like that. Maybe there was there. I missed that. Anyway, I mean, the main topic you should prepare classical mechanics, quantum mechanics, electrodynamics, and that thermodynamics or thermal physics, I would say. Most of the things are mathematical physics. These 5 topics, and some things are off the topic, that is Raman spectroscopic part. If you are not comfortable, then you can leave, but you will not lose much questions, I think so. But don't believe on me. If you have time, you please read that. Okay, because sometimes they focus on some specific topic. Okay, you will see some questions on some particular topic. Most of the questions will be asked. So
Okay, sir.
what we thought at that time, we have some idea which institute is preparing the question. So this time I think IIT Kanpur, right?
Yes.
So IIT Kanpur is famous for condensed matter physics. Okay. So you mostly, my intuition says you will get most of the question from solid state physics and quantum mechanics. But don't believe on me, because I am from IIT Kanpur. So I know about the faculties, and because faculties are making the question, right?
So it's not prepared from that institute.
No, faculties are involved.
Sir, means all IITs are involved, I think.
But main question comes from that IIT. Then it is getting modified. I know, because my guide was involved at that time. Because of I was doing project and that guide was involved. So I know little bit about that. But don't, that is not a fact, okay? That is not a fact. Because if three professors are involved and they are inclined to a field, then you will try to focus on that, because they are expert in that field. But this may not be true. What my intuition says, I have said that. Okay. So solid state physics is a major part, may play a major role here. I mean,
Noted, sir.
yeah.
So, apart from that, after what amount of questions we should think it is enough, and we shouldn't take any more chances?
Okay. Uh, See, this depends on person to person. First of all, someone perspective is that I will attend all the questions, doesn't matter. That is very horrible. Okay. So, and also don't expect that I will attend 80 marks, then I will leave. And even though I have time, first thing is, will matter in competitive exam, doesn't matter how much you attended. Okay. So this was a misconception in my time. So I'll tell one story of my jam exam. I think I attended 60 marks at my time. Okay. And I was really upset after jam. Then I came to know that the question was very hard at my time. Okay. That's why I could not attend more than 60. I was focusing on the accuracy of my solution, not the quality. So basically, you have to prefer the quality over quantity. That's the thing. That is my suggestion. Don't think meanwhile the exam is, you are giving the exam, I am doing the less number of questions. That doesn't matter. And in my time, when I attended only 60 marks, I came to know people have attended 40-45 marks, and okay, I got 19 rank in jam. So I think I got 53 marks. With 53 I got 19 rank. So you can understand the highest who got highest, that was around 60 or around that, right?
Yes,
So
sir.
that's the thing. Competitive exam is relative type of thing. So don't uh, rush with that quantity. You have to attend all the questions. I have attended 50 marks so that my rank will be low, my self-esteem will be low. Don't So try to give your best and try to focus on the accuracy of your solution. Okay. And don't try to guess much. If you sure about 70-80%, not 100%, then go for it. But 50-50, I will not suggest. So you are sure about this, you can cut two options, but you are not sure about among the other options, then sometime you can take risks. That is personal choice, but I will not prefer. That's the thing. I mean, these concepts occurs in our mind when you are giving the competitive exams, right? So that my
Yes, sir.
point of view may be different from you, but what my point of view I have said. Okay. And
Thank
so
you, sir.
you guys are you guys can, what I prefer, you can just first do the aptitude part and finish it. Don't go at the last. Okay. Because physics question are very hectic, aptitude will be little bit easier. So try to finish that. If you are attending 15 marks among 20, that's fine enough. That's fine. And don't waste too much time on aptitude and English part. I think there are 20 marks, right? 20 or 30, I forgot. 20?
Sir, 15 marks.
Oh, 15.
15
Sorry,
marks, 10
15.
questions.
Oh, sorry. I totally forgot. 15 marks. So that is 5 or 5. Total 10 questions. Yeah. And 45 questions from physics, right?
Yes, sir.
Okay. Fine. Then try to cover the aptitude part within 15-20 minutes, and remaining time you should spend on physics. Don't spend much time. Okay. That's the suggestion. That the one mistake I have done in my exam. I spent 30 minutes on aptitude part. And don't know. Okay. Depends on the
Okay,
question.
sir. Thank you, sir.
Yeah. Anything else? I think everything is okay. Okay. All the best, guys. You can send me
Thank
a
you, sir.
mail if you have any problem. Okay.
Sure, sir.
Sure. Thank you. And if you are getting any hello, if you are getting any mail from Input Team for feedback, please try to give a good feedback. That's from my side for my benefit. Okay. Thank you.
Thank you, sir, for your time.
Thank you,
Yeah.
sir.
Thank you.